Hey everybody, my name is Varun Behl and this is a crash course to Java. So to start, let's discuss how Java works. The programming language itself takes source code, which is written in Java, compiles it into bytecode, which is a class file, and then it has a Java virtual machine which interprets the bytecode and turns it into machine code, which is a much low-level version of the code that the machine can understand. This is a sample Java program called hello-world.java. The Java program begins with a class definition, class hello world, which is used to indicate that a new class defined hello world is being created. Hello world is an identifier, that's the name of the class. The main method within the class is a method whose signature is public static void. In this case, public represents that the JVM can execute the method from anywhere. Static represents that the main method is to be called without object. The modifiers public and static can be written in any order. Void indicates that the main method doesn't return anything. And main is a name configured in the JVM. The arguments of an array of strings means that the main method accepts a single argument of an array of strings. The system is a predefined class that provides access to the system within the printline statement, and the out is a variable of type output stream that's connected to the console. The comments are shown in the beginning and at the end in either a /*, which is a block comment, or a // which is a single line comment. Java is commonly used in Java applications, Java web applications, server applications at financial services industries, software tools, trading applications, big data technologies, scientific applications, and many other applications. Java is a compiled language, but it is a portable language that could be run on any operating system and any computer without needing to be pre-installed first, making it very versatile in its use. As mentioned earlier, a main method may have some indicators before it, such as public static void. Public is an access specifier, which means the main method is accessible anywhere. Static helps the main method get loaded without being called by any instance or object. It's called when the program is run. Void clarifies the main method will not return any value. And a difference can be if it says string, it means that the main method will return a string, for example. And main is the name of the method. The string args is a string array to pass arguments at the command line. Args is a variable name of the string array. It can be changed to anything, such as string A. I've been throwing some terms around, including function, method, and class. A function is a piece of code that's called by name. It can be passed data to operate on and can optionally return data. All data that is passed to a function is explicitly passed within its arguments. A method is a piece of code that's called by name and is associated with an object. In other words, a method is a function but is within an object. A method is implicitly past the object on which it is called. So if a method is in an object, it has access to some of the internal objects within a class. A method is able to operate on data that is contained within the class. As I just mentioned, it can deal with some of the data as well as change some of the parts of a class. A class includes methods. It's an object as opposed to a method, which is a function for a class. How about importing? What is an import? An import is run at compile time to show the compiler where to find a piece of code. Once found, the methods of the imported function are brought into the current code. That way, one piece of code can use classes and functions that's within another piece of code without having to explicitly direct the code into the file. For example, if you import Java lang, you can say string instead of java.lang.string. Now for a good syntax in Java. Some good syntax includes class ordering. So when you create a class, you want to have the fields come first, followed by the constructors of the class, followed by the methods. This makes it easier to read for users who are trying to understand what a class is. If you have the fields throughout the code, it'll be very hard to find. Lines in Java should be no more than 120 characters. While coding in Java, you want to avoid do-while loops, continues, returns in the middle of the method, and breaks outside of switch statements. Additionally, if you want to make a class or make brackets, you have to indent, and indents should be 4 spaces each. All fields should be private, in a class especially, except for some constants that might be used in different locations. Finally, JUnits. JUnits are created generally before in test-driven development or after a piece of code is written to test its functionality. In this case, we have a piece of code or a class with a concatenate method that takes either strings or integers and returns the addition of the strings or integers. Now, these are some tests that can be run on the previous class. One test is to add 2 strings, which is the test concatenate strings. That test takes 2 strings, asserts that the 2 strings added together is the addition it should be, and then if it is, it'll return true, and if it's false, the test will fail. Next, we have test concatenate integers, which takes 2 integers, runs a concatenate function on them, and then asserts that the addition of the 2 integers should be correct. A third test is to test negative integers, and it puts the negative integers into the concatenate function and then asserts that the negative integers add up to 0. If any of these fail, the IDE or whatever is compiling the code will return a notification that a test has failed. Sometimes a code will break on an exception. An exception can be an array out of bounds exception or a file not found exception, basically a case that was not thought of while writing the code, but that the code ran into. For example, if you try to iterate through integers 1 through 10 an array of size 5, at the 6th point in the array, it may give an array out of bounds exception. What a user can do is put the exception in the try catch block, so you can do try iterate through array, catch this exception, and then do something in response to the exception, or you can run a finally method to maybe undo any changes you made. So if it breaks out of a specific function, it won't break everything. If not caught, an exception will, may, and can abruptly terminate a function. Now we talk about integrated development environments. These are commonly used by programmers to code Java. Integrated development environments, or IDEs, make life simpler for developers. It autocompletes methods, imports, and simple actions, so you don't always have to import a specific function. You can just type in a function and it'll cache all the data. So if it realizes that you're calling a function from a different file, it'll recommend that you import said file. Compilation is done through one button rather than having multiple java run commands. Debugging is also easy because you can just set a breakpoint. We'll talk about breakpoints in the next slide. You can use IDEs to debug in a method that steps through a function, and you can view each variable as it shifts and realize why a function broke. Additionally, you can simplify a piece of code by minimizing methods as well as importing different add-ons that might make development easier. Two popular Java IDEs are Eclipse and IntelliJ, which are both good for different reasons. IDEs also support other languages like Python or other parts of Java like JUnit and Android development. Some IDEs allow you to make a specific JUnit file, and it can automatically import all of the functions to make test stubs for each function. Others allow you to make a JUnit file that automatically imports all of the JUnit functions as well. Android development is also useful in IDEs because it can set up the UI of a phone so a user can easily test it on a prototyped machine. Now we move on to debugging, which is the last topic in this slide. Debugging allows a user to step through code and see any variables as they change. These variables are the current variables that are in the function, and a user can see them at any given point as they step through the function. To debug code in most IDEs, you put this red dot, which is a breakpoint, on any point where you want to start debugging. Once you click Run Debug Mode, it'll go into the breakpoint and stop at the breakpoint. You can then step through the function and see how anything changes. Additionally, you can also step into a function. For example, if you want to see what happens within a put string, once it gets down here, you can go into the postpage.putString and see what happens inside of it in case a break happens within it. You can view any local variables, and you can also highlight any area. For example, you can highlight PP and see what it currently evaluates to. At this point, an assertion is created. This is the message that happens if the assertion fails, and then it compares two separate things on the right side. So yeah, that's pretty much how debugging works. You can just step through it and generally have an idea of how the whole function gets created and runs. Honestly, debugging is just a really useful tool. You can see if an if statement gets skipped or a for loop ends earlier than you expected it to. In general, it's one of the most powerful tools you have, and as a developer, it's something you should really take advantage of while using an IDE. And here are some references I used. Thank you for listening, and I hope everyone who watched this got a good understanding of the basics of Java.